Hey everybody, this is my third generation open source 6-axis robot. If you haven't seen this project before or the previous AR2 robot, this is a project I started a couple years ago. I'm a robotic systems engineer in my day job, and I set out to build the least expensive robot I could. I wanted to learn robot kinematics, and I wanted to build my own controls program. So I wanted to build a robot that was usable, that could reach around 60 centimeters and have a payload of around 2 kilograms. So I built the first one and put it out on YouTube and got quite a response. So I decided to make it open source. So all the software, the print files, the instructions, and I wrote up a complete set of manuals for the robot, and that's all completely free. So, anybody can build this robot. I started up a small website to host all the files. So at the end of this video, I'll show you where you can get all that information and how you can build this robot yourself. Industrial robots are typically around $30,000, and I didn't have that kind of money. I get to play with them at work, but I wanted to build my own. So I designed this robot so that it could be built from either aluminum, or as you can see here on the right, this one is 3D printed. It's all the white components are ABS, so it's completely 3D printed. And then the aluminum one, of course, the covers and the spacers are all 3D printed. But to build this robot 3D printed, it's around $1,500. Out of aluminum, it's around $2,000. I tried to keep the cost. That was the whole goal of the project, was just to keep the cost as low as humanly possible. All of the bearings, the belts, pulleys, all of the components were all off the shelf components that you can get from Amazon or AliExpress. The main difference between the AR3 and the AR2 is that the AR2 was open loop. The AR3 is now closed loop, meaning that I've added encoders to each axis. So the robot can retain its position. If it gets bumped or crashed, it will be able to recover and know right where it's at. I've also upgraded all the covers and spacers and the print files. They have wireways now. It has a built-in base enclosure. I've cleaned up the wiring harness and made a much better wiring harness for it. The main structural components are still the same, so if you've built the AR2 robot, you can very easily upgrade to the AR3. I've tried really hard to keep everything backwards compatible. And then, in addition to the encoders, the AR3 still keeps the limit switches to do the auto calibration. So, most robots, you have to jog the robot to a timing mark position to do the calibration. On this robot, you just click auto calibrate, and the robot will run to an auto calibration position. I got a demo set up here, and so we'll go through that, and then after the demo, I'll show you some more information on the controller, and I'll show you the auto calibration, and then maybe I'll do like an on-screen video and go over where to get all the software and all that stuff. So the two spools of 3D printing filament there that the robot just lifted weigh 2.2 kilograms, or about 5 pounds. Um, I have the robot's payload capacity listed at closer to 4 pounds, or 1.9, but just wanted to demonstrate how much the robot can lift there. So another thing I wanted to demonstrate here was the robot's auto calibration. There's limit switches on each axis. So in the software, if I click the auto calibrate button, you can see the robot will move to its full limits, and it will fully calibrate axis 1 through 5. It'll come off the limit switches, and then it will slowly come back onto them and calibrate each of those axes. Then it will go vertical to the rest position and calibrate axis 6 separately. Sometimes when it's in that crouch position, the wiring harness can get in the way of the limit switch, so I have it calibrate axis 6 separately while it's vertical like this. So now the robot is completely calibrated and the software says auto calibration complete. So the other thing I wanted to demonstrate was the encoders and the closed loop capability. So if I hit the e-stop button here and shut off power to the motors, I can manually turn them. So I'll turn axis 1 a little bit in the negative direction, and then I will turn axis 4 a little bit in the positive direction, and then um, grab the camera. And if you look here at the screen on the computer, you can see there's an error for out of calibration. And if you look at the log screen, it'll tell you axis 1 and axis 4 um, are out of calibration. So now if I go hit execute on the rest position to run it back to the rest position, it automatically recovers and goes perfectly back to the position it was at. So if you're jogging the robot and you crash into something, or you have a program that crashes into something, that's exactly what will happen. The robot will just stop. The software will say that there's an error, and then when you hit play or forward on the control software, it'll continue where it left off, like you saw there. So I put together this website to host the project. I'll put a link in the description. If you come here to the tutorials tab, I have a number of video tutorials. So I have a setup and startup video for the AR3 robot, and then I have a whole bunch of programming videos for the AR2 robot. All the programming videos for the AR2 are all applicable to the AR3, but I will be making more updated programming videos for the AR3. Here on the downloads and manuals tab, here at the top we have all of the downloads for the AR3 robot, and then down below that we have all the previous downloads for the AR2, and then a download for a manual for building a 7th axis travel track, and I will make another video for the travel track on the AR3. So for the AR3 downloads, the software is all open source. So right here on the left is the source code. So you could download that and have access to the Python files and edit those and play with that as much as you want. Or if you just want the executable, you could download that. And so the link for that is right here. So I will show you the software real quick. So here's the control software for the robot. Over here on the left, you have a program window, and then you have a play button, stop button. Up here in this area is all the jogging buttons to jog the robot, either in joints, degrees, or in Cartesian, XYZ, millimeters, or by a tool. In the programming window, you can add add as many functions as you want. So for example, a joint move, I could just click teach new position. It puts that new position in the program, or I can change to a linear move and put that in the program. Or there's also arc moves, circle moves, offsets for like stacking blocks and things like that. You can modify a position if you're over the top of it and just click modify. You could delete a line like that. You can call programs, so if I wanted to call the home program, I could just do that, and it would put that right where the cursor's at. There's a wait time, for example. I could wait for 5 seconds and put that in the program. You can wait for inputs from the Arduino to come on or off, or you can set outputs on or off, which is how I'm controlling the gripper. For example, I could just put that in the program. So there's all of that for adding stuff to the program. There's the calibration tab. Here's where you auto-calibrate the robot. For testing and setup, you can calibrate the robot at a rest position. There's a fine calibration. You can calibrate joints individually. Um, and then there's also all of the parameters for the robot. So if you've built your own custom robot, you could come in here and change all of the Denevitt-Hartenberg parameters for the reverse kinematics. There's an input outputs tab, so you can control servos and turn inputs out and off, inputs on and off. So for example, here I have output 28, which is what I was using for the gripper. I can open and close my gripper by clicking those buttons and not have to come in here and execute a line of code to get the gripper to open and close. I could just do it from clicking a button right here. We have a registers tab where I have 16 different registers that can be used for counting in the program. So you could count and increment, stack blocks, stuff like that. And then there's also stored position registers here. So the XYZ yaw, pitch, and roll of a position, you could put that into a stored position and then reference it in the program, or offset by a stored position for stacking and things like that. There's a vision tab. I set up the vision for a couple of basic open source vision programs where it just outputs to a text file and then the robot can pick that up. And there's a video on my YouTube channel on setting all that up. That is something that I want to work on in the future. One of my goals is to create my own integrated vision and use OpenCV and have a vision program in here. So that is something that I want to work on pretty soon. There's a log tab here, so to log any errors that you see, and then there's an info tab which goes through and talks about the speed, acceleration, jogging, programming, and just kind of goes through a bunch of details of the program there. So that's that. Going back to the website here, in addition to the software downloads, we have the Arduino sketches to put on the boards. We're using a Teensy 3.5 to control the robot motors and encoders, and then we're using an Arduino Mega. I've left that in the architecture for a kind of an I/O board. We can use this to control inputs and outputs, grippers, servos, things like that. So the Mega is a nice little 5-volt board that can do all kinds of stuff, so we've left that in. And then the 3D print files, so those are all here. So you can download all the 3D print files to print the covers and spacers, or if you want to make a 3D printed version of the robot, that's all here too. So you can download all of the 3D print files. And then we've got the assembly manual, so I'll show you that real quick. So I put together a full assembly manual for the robot. We've got chapters on the bill of materials, the robot assembly, enclosure assembly, wiring diagram, some information on the gripper, some specs on the robot, startup procedure, some programming, and then I've got some notes in the end for an open loop version. So if you've already built the AR2, or you already have the the motors, the motors for the AR2 that are not dual shaft for the encoders, and you want to build a closed loop version of or an open loop version of this robot and still build the AR3, you can do that. So just going through the manual, there's just put a ton of detail on a number of things. It goes through bill of materials, so all of the components that you need to build the robot, and it shows you where to get all those. And then we've got instructions for down a little bit. We've got full instructions for assembly of the robot. So I go through step by step, every screw, every step on how to put together the robot. And then go down a bit further. There's instructions on the enclosure, how to build the enclosure. So again, a ton of detail on that. And then below that, we've got some schematics, some wiring diagrams here, so show all of the wiring, pretty detailed. So anybody should be able to build this robot pretty easily. So anyway, that's the manual. Going back to the website, I have a tab for robot kits. So it says here there are 5 groups of parts needed to build the robot. So we've got covers and spacers. Those are the parts we 3D print. We've got the structural components. These are the 27 main structural components. So you can 3D print those, or you can get them out of aluminum. And there's the hardware components. These are the bearings, belts, pulleys, sprockets, chains, shafts, those types of parts. And those are all shown in the bill of materials, so you can source those yourselves, or I have a kit here where you can get those. I've had quite a few people asking me to provide kits for the robot. So down here I've got an aluminum parts kit, a hardware parts kit, um, and so moving on from the hardware kits, the fourth group of components is the stepper motors and drivers. Those you would acquire directly from Stepper Online. They've been the lowest cost source I've been able to find for any of this stuff, and they've got a lot of really good selection of gear drive stepper motors. So down here, these two items on the Robots Kits page, these are links to their website where you can buy the complete AR2 package or the complete AR3 package for the motors, drivers, and all that stuff. And then finally, the last group of components is electrical components. And again, these are all laid out in the bill of materials. This is the wire, the connectors, the enclosure, the Arduino, just the miscellaneous electrical stuff. And that's all stuff you can get on Amazon or AliExpress. Uh, and I've had quite a few people asking me to put together a store on Amazon store or provide these. So I'm looking into that. I'll see if that's something that I want to get into. Um, so also on the website, we've got a forum. So there's a lot of cool stuff on the forum, a lot of people on here. So we've got a general discussion and questions and robot builds. So people share a lot of cool stuff on there. So it's been a lot of fun putting this website together. So a few other things, if you wanted to do like offline simulation, it's kind of cool. RoboDK put together a library for the robot. So if you were to open up the RoboDK software and open up the model for the robot, you can see here you can do some offline simulation. Kind of cool. And then if you come to my YouTube page, I've got a playlist for the robot user builds. So we've got a lot of cool stuff here. Like you can see here, we've got the Robo Cafe. Somebody's got the robot set up to serve ice cream. I thought that was really neat. We've got welding. Set the robot up to do some welding there. Just a number of cool stuff. Cinematography. Somebody's using the robot to do some filming. So that was pretty neat. And then if you're into ROS, the robot operating system, if you're into that, if you come here to my GitHub page, that is Chris-Annan at GitHub. I've got the ROS AR2, the URDF. So this is the URDF file for the robot, and I've also got some MoveIt config set up. So if you're into ROS, you can play with that. And you can see here, Nicholas from France has got a post on the website where he has set up the AR2, and he's got a GitHub repository here with some stuff where he's used the AR2 with a Kinect sensor using the ROS operating system. So really cool stuff. People have been doing a lot of neat things with the robot, and it's been exciting to watch. Yeah, the project's been a lot of fun. I've had a blast with it, so I hope everybody enjoys the project. Thanks for watching.